Hi, Mike Madge with Small World Big Data, and today we're talking about something a little bit different than our normal IT infrastructure stuff. Today we're going to talk about sort of the future of how everything gets programmed, the applications, and what's coming next. I have got an exciting actual concept here to talk about with Liam Randall, who's CEO of Cosmonic. We're going to go through what they're up to. Just as a hint, it starts with Kubernetes and goes from there and into the brave new world. So let's get into it a little bit. Welcome, Liam.
Thank you so much for having me on today. I really appreciate it.
Okay, let's just start with a little bit of your background. You have been on the forefront of application development, DevOps, and things for at least a decade now. You
Yeah.
are a luminary in the field of Kubernetes. What are some of the things you've been involved in and seen that have gotten you here?
Yeah, absolutely. I started my career working on protocol analyzers for a project called Bro, doing large scale network monitoring. And it really gave me this world view of instrumenting and looking at millions of the world's applications that we still had a long way to go in application architecture and application development. And I was very involved in the early days of Kubernetes and containers. And actually, I launched the very first Kubernetes company in 2014 called Critical Stack. It was a huge hit. We did 5 million revenue in the first year, and I ended up actually selling the company to Capital One Bank, where I went on to lead innovation and owned all open source for just one of America's most innovative tech companies.
And they have a lot of applications too in that space,
They
right?
do
That's
absolutely.
tens of thousands of things, I'm
Yeah,
sure.
and that was the sort of the insight that I had from getting to go about thinking about how do we build trees of applications to how do we manage forest of applications, and we sort of observed this frustrating pattern that every time we wanted to build an application, our developers, even if we gave them templates that tried to cross out as many of the requirements as possible, were really mired in the complexities of building an application. And there was a lot of repetitive work that happened on each and every application over and over and over again. And while we were obviously using containers, and containers are great, containers don't fix the applications. And containers have been a wonderful steward for the last 10 years of computing, which is the great lift and shift. How do we take the applications we have and move them into the cloud? But really, when we started to think about how did we build truly cloud native applications that are portable across clouds, when we think about building truly cloud native applications that are portable across edges, we suddenly needed to start thinking differently. And we launched an open source project called wasmCloud in 2019. That's now a CNCF project and has incredible traction. And from there, that led to the genesis of Cosmonic.
Okay, so wasmCloud WebAssembly based technology is
Right.
what the W is for. Uh, and just in the broad brush, when people move into some new territory, I would say in my career I've noticed that first they care about functionality. So I can move my application to the cloud and it runs. A great Kubernetes, it runs. Clap clap. And then next they're going to care about availability and service levels, and then they care about performance at some point and scalability and can I really make this thing? And finally they care about eventually security and can I actually close the doors on this? And all those IT things creep back in on
Right.
there. And I guess what you're saying is we've seen application developers turn into DevOps people more responsible for those things than writing the code that they're supposed to be writing. And
That's right.
is that kind
Yeah,
of what you
that's
guys see?
absolutely right. The
Yeah.
early talk that we gave on wasmCloud was from napkin sketch to the cloud. Because what we really the chasm that we really want to cover is I have an idea, I want to build some application, and then how do I take it into production and scale it and start worrying about those illities of software. Reliability, availability, security, all of those other non-functional requirements. Because those non-functional requirements oftentimes get pulled early into your roadmap and you start to pollute your application thinking about the topology, about what kind of a database am I connecting to. So wasm cloud adopts what's called an actor model, and we essentially give you a box of legos that are common components that you can plug in that are very generic. So you'll say I want a SQL database and a message queue and a value store and a key vault for my security. And then at runtime, those can be connected to specific devices without changing your application. And for example, our SQL a store supports RDS, it supports MySQL, single store, Microsoft Cosmo DB, and other things. So it's hot, swappable, and pluggable underneath. At the business level, we adopt a model of being stateless and reactive. So think of wasmCloud as sort of an open source Lambda. And what's powerful is that you can run it across any cloud, any edge, even your own devices, anywhere, using the open source. And applications are automatically cross connected, so you can seamlessly migrate or scale an app into different clouds or edges as you see fit.
All right, so there's a couple things there just to peel this back apart. We've made a fluid layer across from an application developer to the Lego bricks that they might want to consume. So if an
Right.
application says, I need a database, they say I need a key value store. On the back end, somebody else can hot swap in different key value stores in different places as needs connect. Okay.
That's right.
Then you talked about this portability, fluidity of I can run that little now that bit of code that I've written in many different places without changing it.
That's right.
Is it right?
Yeah.
And they can talk to each other no matter where they're running, which is kind of mind blowing because I was like, okay, it's one thing to say I can move my Kubernetes cloud from Google to Amazon or Azure, but it's another to say like I'm taking pieces of that and moving them to different clouds and they're still going to communicate to each other.
Yeah, so there's two layers of abstraction here. The first is the sort of logical layer on rather than binding your application to a specific database, you bind it to a contract. And these contracts are easily extendable, so what's powerful is if you're somebody like Intel or BMW or two of our developers, development teams in our user community, they just contributed a machine learning extension. So it's pluggable. You can add your own Lego blocks as you need them. We ship what are the most common Lego blocks that we see in most applications. And then we use WebAssembly for the actual compilation. So we take your app, and the reason why we use WebAssembly is it's a very powerful and new technology. Think of WebAssembly as a tiny little CPU that is already running everywhere. It's only the fourth language of the web. It's already running, and it was designed for front ends and browsers. But I genuinely believe that the bigger impact will be on the back ends. Because even within a single cloud today, let's say that you're just building an app that's only going to live in AWS, you suddenly now have different CPUs that are available to you. So let's say if you build initially for x86, and then you want to start using those new Gravitrons that are 40% less expensive, you can easily migrate your application all without recompiling it. And that problem is really compounded when you start to think about the diversity of down-market CPUs. So WebAssembly in itself is a gigantically huge idea from a singleton, and the way wasmCloud as an application framework works is any WebAssembly process that's united in a wasmCloud instance here is sort of accessible via wasmCloud. There's a layer that's based on NATs, a message bus, so that as your business logic wants to talk to capabilities, those capabilities can live anywhere. You could be running in AWS and use capabilities in Azure or in GCP, or you could be running on the edge and using a database in AWS, or vice versa for that matter.
So it really takes the sort of the promise of portability that containers had and makes it real in several different directions, right?
Yeah, I think that the idea is an idea that's not necessarily new or necessarily innovative. When you think about Java and Silverlight and Flash, there's been lots of things that had the vision of write once, run anywhere, except they were all sort of, driven by a single entity, a company, which meant, one, they were plugins. They weren't going to ship by default on competitive platforms. And two, they were a bit overly opinionated. They came with their own languages, for example. WebAssembly is the industry coming together, and I think the industry is always better together and agreeing on a standard that works for everybody. Microsoft.net just did a talk where they're supporting writing outputs to WebAssembly. So you start to have this weird world where you can write applications and move them into browsers. This whole even segmentation between the idea of front end and back end becomes a bit more fluid when you start to realize that we now have compute platforms like that are based on and around WebAssembly, like wasmCloud, that allow you to sort of seamlessly execute those things on demand. And the broader theme here is really, the last 10 years was this great lift and shift into the cloud. The next 10 years is all about bringing your compute to where the data is. And data locality laws and privacy and regulation, or even the desire for limited or deliberate autonomy, there's lots of reasons why that compute needs to go to those edges and it needs to be able to live there, but also seamlessly work into traditional cloud architectures as well.
So this is really about you know, creating a truly distributed architecture or distributed set of services, and where the services can now truly live where they best need to for either service levels or cost or whatever levers you want to push up and down.
You're absolutely right.
Yeah.
And ultimately, I think that wasmCloud gives you a huge lift up and advantage, even if you are riding a local lift, a micro lift running in a single place at a single time. But what wasmCloud truly enables is this ephemeral topology. Topology becomes a runtime configuration. Where I'm executing becomes a runtime a configuration. What databases I'm using become runtime configurations. We're no longer, just as we've abstracted away from CPUs with virtualization and clouds, operating systems with containers and cloud APIs with Kubernetes, the next great abstraction is the abstraction of the application components and libraries. And that even itself is not a necessarily novel or new idea. Istio, which is the second most popular application in the CNCF after Kubernetes, says, hey, at a layer 3, at a network layer, all applications need to support these common services. So let's stop putting them in the application and instead make them a part of a common rail that applications can just plug into and connect to. Our observation is why stop at layer 3? If it's good at the network and the authorization layer, let's continue to pull that stack up all the way to the business logic. And what we really want to do, our mission is really just to bring joy back to development. Rather than be mired down and learning the intricacies of how do I build this and lock this down and secure this on this specific cloud and this specific place and this specific time, I can really close that gap, that chasm between napkin sketch and getting something into production.
That time to market is all important. I think people are just moving faster and faster and faster. So, how would you describe this to wrap this up? WASM Cloud and Cosmonic, you're offering platform as a service. Is that
Right.
fair? How would you
Absolutely.
say that? Yeah.
Yeah, wasmCloud is and always will be open source. It's got a gigantic community that's around it. We hit that point where it made sense to be a part of the CNCF, and it looks like we're now well past that point where we are going to apply to go incubating there. So if you are interested, we've actually launched some free learning labs. You can go to labs.cosmonic.com or just visit wasmcloud.com. You can join our Slack right from there. You can drop right into some real-time interactive labs without installing anything, and you can start walking through tutorials and building your own distributed applications. For those companies and enterprises and developers that are really looking for the get commit to run experience, that's what we're building Cosmonic for. Cosmonic uses wasmCloud. We're the key contributors and leaders of wasmCloud, and wasmCloud gives us some phenomenal advantages. Because we've pulled all of those non-functional requirements out of our applications, your applications, when you build them in wasmCloud, are tiny. Think 20 kilobytes or at most a couple meg if you've got dependencies and debugging information pulled into your WebAssembly binaries. So when you're looking at how we can scale and run these things, we can bin pack these things orders of magnitude more dense than what you get with containers. So there's a lot of compelling advantages from not only time and speed to market, but also in operational efficiencies for organizations that are interested in exploring these technologies.
I mean, I like this story, Liam, because we're going from physical machines to virtual machines to containerized services now to this WebAssembly concept of little application portlets or portable applications. I'll come up with a word for it. That's what our
Yeah,
job is on there. But we're not talking about necessarily driving things into like a low code, no code, don't touch it, and just your thoughts will make the Excel spreadsheet work right, right? It's like this is
yeah.
still making application developers relevant doing what they do best.
Absolutely. Look,
Yeah.
low code platforms
Yeah.
have their place, but low code platforms are not typically low boilerplate platforms.
Yeah.
What we really want is right code. And what that means is the right architecture from an application perspective, and it means letting your developers be creative and imaginative where they're adding value, and then making those core business functions, those requirements, a part of the platform. If all applications need to have, say, distributed tracing, for example, or
Yeah.
OTel,
Right.
why do you want developers to do that on an app by app basis? If we've built our platforms properly, you can simply add it in the platform, and believe it or not, we just rolled out OTel in wasmCloud. So all the open source users of wasmCloud, all of their applications can now simply export those OTel settings right to Honeycomb or Datadog or whatever application it is that you're using
Yeah.
for building and managing your OTel. It's
Yeah,
powerful stuff.
really strong leverage. Okay, so check out Cosmonic, check out wasmCloud, folks. It is what's next after Kubernetes and containers. So definitely worth your time and effort to click a few buttons here and do a little research. So thank you again, Liam, for being here today and explaining that to us.
Thank you so much for having me on. It's such a pleasure to have an opportunity to not only spend time with you and your team, but also your guests and audience. You can reach out to us anytime on Twitter, on Slack, or hit us up on the web at cosmonic.com.
All right, thanks. Take care.